Welcome to Part 2, Key Statistics Vocabulary. We will cover some general but important statistical terms in this section. Feel free to watch and listen to the presentation on a specific term and pause in order to look at the resources provided on this topic. As with the first section, please make sure you read and/or watch the resources provided in order to assist with your understanding of the terms. Seek out additional resources as needed. Types of statistics. There are three major types of statistics. The first is descriptive, and these attempt to describe data so that they can be easily understood by the consumer. They will summarize the data in many ways, such as averages, percentages, frequencies, and proportion. This is considered the hard data of research. As addressed earlier when discussing survey research, the second kind of statistics are correlational. These types of statistics will describe relationships between two or more variables. You may be able to identify a relationship or perhaps predict or indicate some type of cause and effect between variables. The third type of statistics is called inferential. This is where you, quote, make sense of the data, unquote. According to Patton and Newhart, 2018, inferential statistics are used when the researcher wants to generalize the results to the population on the basis of the sample which was used in a research study. Inferential statistical tests are necessary to determine if patterns are in fact a significant estimate of the population or if they can be explained by sampling error. This information comes from page 204 in their textbook. Inferential statistics are based on probability. This means they estimate the likelihood that something will occur. The researcher will conduct significance tests with the descriptive data. Two commonly used statistical tests are the t-test and ANOVA, which are addressed in the third section of quantitative research. These tests will determine whether there is a significance in the data or the results occurred because of sampling error. Scales of measurement. In order to understand the scales of measurement in research, we must first address the properties of scales of measurement. Each scale of measurement satisfies one or more of the following. First, identity, which means each value has a unique meaning. Secondly, magnitude. This is when values have an ordered relationship to each other. For example, larger or smaller. Third, a scale of measurement may have equal intervals. This is where the units are equal to each other. For example, the difference between 1 and 2 is the same as the difference between 19 and 20. Finally, a scale of measurement may have a minimum value of 0, which is the true 0 point below which no value exists. Now, let's make sense of these properties in terms of the four scales of measurement. The first scale of measurement is nominal. The scale simply names or categorizes responses and fits the property of identity discussed in the previous slide. Normally, this will be a verbal classification as opposed to numerical. An example of this is male or female. This is the lowest level of measurement, and you do not apply any type of ordering of responses in this nominal level. An example of this would be your favorite colors. There is no difference, no order, no value in red, green, blue, purple, or yellow. It is simply a naming value. The second scale is ordinal. This not only fulfills the identity property, because the ordinal level will name something, but it also achieves the magnitude property, because there is an ordered response to the categories. Though you cannot tell the difference between the ranks, such as the differences between likely and highly likely, or the difference between good, better, and best, because the order does not correspond to something that is quantifiable, you can still rank the values and determine that one is higher or lower than the other. The next scale is The next scale is interval. As you may have presumed, this scale of measurement includes identity and magnitude, as well as equal intervals. In the interval scale of measurement, order is meaningful. However, there is no true 0 point. Put in simpler terms from the Patton and Newhart 2018 text, interval scores typically measure scales of different types, and a typical example given is reading the temperature in Celsius or Fahrenheit, where we know there's a 10-degree difference between 45 degrees and 55 degrees, or 55 degrees and 65 degrees. Interval variables are not on a number scale in which 0 means an absolute lack of characteristic, i.e., we do not have a lack of temperature. The final scale, which contains all 4 properties, identity, magnitude, equal intervals, and a minimum value of 0, is a ratio scale. This is the most meaningful scale of measurement. An effective example of this scale is weight. If you weigh 140 pounds, this is a specific value, it is ordered, and we know that it is more than 130 and less than 150 pounds. We also know the differences between weights are equal. We know 140 pounds is 10 pounds more than 130 and 10 pounds less than 150. Finally, there is a true 0 point, which means there is a lack of quality or characteristic. There can be 0 weight. The true 0 point also indicates that the numerical values compound meaning. That 100 pounds is twice as heavy as 50 pounds. Scales of measurement are an important statistical term to understand because a researcher must know what scale a variable or variables fall under in order to determine the statistical test to run to analyze the data. Variables. Another key term in quantitative research is variable. A variable is a trait or characteristic that can vary within a population and must have at least 2 categories. For example, male or female, GPA, body temperature, etc. Variables are categorized using the different scales of measurement. They can also be categorized into 3 distinctions as the one listed here. A quantitative or continuous variable, think numbers, are the variables that are in the interval and ratio scales of measurement. Remember, these are both scales of measurement with equal intervals between numbers, and the ratio scale will have an absolute 0. The second distinction is rank. This is for the variables that fall in the ordinal scale of measurement, where variables are simply naming and in some type of rank order. The third distinction is qualitative or discrete. The variables in this category fall into the nominal scale of measurement as they qualify or define something, i.e., naming. So, as you are reading research projects and the authors are discussing the variables of the study, you will now be more familiar with the different types and classifications. Again, the ability to understand the type of variable in a research study is very important because it will determine the type of statistical test that is used. Many of you are very familiar with independent and dependent variables. You know that independent variables are considered variables that may or may not impact the dependent variable. The independent variable is the cause and the dependent variable is the effect. Mediating, moderating, and control variables can impact research and the actual impact of the independent variable on the dependent variable. Measures of central tendency. Measures of central tendency is a term that is used to describe mean, median, and mode. Of the 3 terms, the mean is the most important in research, even though it can be misleading at times. The mean is found with interval and ratio data. As you are likely familiar, the mean is the average of the scores or data set. The median is defined as the middle score. As a refresher, if you would line up the scores in order from low to high and then count to the middle number, that would be the median. The median can be used in place of the mean when data is highly skewed or if using ordinal data. If you recall, ordinal data is when you rank a set of scores. We will talk about skew in the following sections. The mode is not frequently used in formal reporting because there can be more than one. The mode is the most frequently occurring score. If the mode would be used, it is most likely to be used in the nominal or naming scale of measurement, and it can be used with highly skewed data. Standard deviation. According to Patton and Newhart, 2018, a set of scores is described with two statistics, the mean, which describes the average, and the standard deviation. The standard deviation is used to describe the variability of the scores. Variability refers to the amount by which participant scores vary or differ from each other. Please look at the three data sets on this slide. As you can see, the average of each of the groups is 15. However, note the differences in variability of the scores. In Group A, the data varies from 0 to 30. In Group B, the scores vary from 14 to 16. And in Group C, each of the scores is 15. As a consumer of research, you need to pay attention to more than just the mean. In Group A, the variability of the scores is wide. Data indicates a range from 0 to 30, whereas in Group B and Group C, the standard deviation is much smaller because the scores either only range from 10 to 16 or they are extremely consistent with 15s across the board. Whatever treatment Group C was exposed to resulted in very consistent results, whereas Group A's treatment resulted in a great deal of variability in the scores, even though it has the same mean as Group C. Standard deviation also has a special relationship to the normal curve, and the normal curve is a concept that you will need to think about not only as a consumer of research, but as a researcher as well. You are likely familiar with the normal curve through prior research or even standardized test scores. Without too much attention to the numbers at the bottom of the curve, you can see that the mean will be the middle line or the center of the curve. Then, to the left and right of the mean, each of the different color blocks is one standard deviation from the mean. If a distribution is normal, 68% of all scores will fall into one standard deviation from the mean. As you can see from the numbers on the top of the screen, 34% to the left of the mean and 34% to the right of the mean equal 68%. You will then note the next standard deviation to the left and right each cover 13.5%, and the third standard deviation from the mean covers 2.5%. So let us say that we have a data set and the mean is 25, and the standard deviation is 5. We will assume that the distribution of these scores is normal, meaning that there is not a large amount of outliers, i.e. too many low or too many high scores. If the curve is normal, 68% of these scores will fall in between one standard deviation above and one below the mean. This means that 68% of the scores will fall between 20 and 30. Because you simply add 5 to the standard deviation above and subtract 5 to get the standard deviation to the left of the mean. In order to cover 95% of the scores, you would again subtract and add 5. So the second standard deviation from the mean in the 13.5% area would be 15 and 35. So 95% of the scores would fall between 15 and 35. Finally, the third standard deviation would cover 10 and 40. So ideally, 100% of the data set would fall between 10 and 40. Shapes of distribution. We have just discussed the normal curve. There will be times when the data collected will not be, quote, normal, but there will be significant outliers in the data, i.e. extremely high or extremely low scores. When this happens, data can become skewed, and rather than a normal curve, as we saw when addressing standard deviation, the curve will have a tail that will either pull to the left or to the right. When thinking about skew, think about a number line with 0 in the middle. When the majority of the scores fall in the range above 0, but there is a batch of scores that fall below 0, the tail of the curve will pull to the left and it is considered a negative skew. An example of this would be a large basic math test given to a group of high school seniors. Many will do well on the test and the result will be positive. However, some will score low and cause the negative skew in the data. Positive skew is where the majority of scores are toward the left of the 0 point, but there are a few scores to the right. So the left of the curve will be high and a tail will pull to the right. An example of this would be income. Most individuals earn relatively small amounts of income, but there will be small numbers of very rich. Hypothesis, a prediction of the outcome of a study. You are likely familiar with the word hypothesis, and you know that when we were young, we learned that a hypothesis was an educated guess. The hypothesis is the basis of your research study, i.e., what you are going to study. The hypothesis can be phrased different ways depending upon the focus of your research. Oftentimes, you may find yourself reading or implementing a research purpose as well. As you can see, a non-directional hypothesis states there is a difference, but does not predict the direction of that difference. A directional hypothesis predicts there will be a positive or negative change, relationship, or difference between the variables. The null hypothesis says there will be no difference between the two variables or groups. Finally, rather than a hypothesis, research may either have a purpose statement or a question. The research purpose statement will state the purpose of the research. It is similar to a non-directional hypothesis. The research question basis for research is similar to a non-directional hypothesis, and you just need to make sure that it is not a question that can be answered with a yes or no answer. Validity and reliability. Validity is a concept that is used in relation to measures, which is a generic term for measurement devices such as tests, questionnaires, interview schedules, or personality scales. Validity helps the researcher to determine that the device is measuring what it is purported to measure. There is no perfect measurement tool, and therefore a researcher will determine how valid a measure is, not if a measure is valid or not. A test in school is a great example. Let's say that a social studies teacher has her students memorize names, dates, and figures regarding the Civil War. A test that asks these questions in, say, multiple choice format would be a valid assessment in this case. However, if she were to instead ask about the impacts of the Civil War on women and children, this assessment would not be valid. It is important that the device a researcher uses to measure a concept is a valid measure of that concept. A measure is said to be reliable when it yields consistent results. A couple of things to remember when you are thinking about validity and reliability together. Number one, a test with high reliability may have low validity, meaning I can achieve consistent results over and over again with an assessment, but my tool may be weak. Number two, validity is more important than reliability. It is more important to have a tool that measures what it is purported to measure than one that gives consistent results. And number three, to be useful, a measure must be both reasonably valid and reasonably reliable. In this presentation, we covered key statistics vocabulary. Please make sure to study the resources provided